Hi, welcome. In this session, let us see the relationship between units and dimensions. First one, here, if you know the dimension formula of any physical quantity, you can easily find out the units. Similarly, if you know the units of a physical quantity, you can easily derive the dimension formula. Let us say, example, impulse. Impulse. What is impulse? Impulse is force into the time. Force into time. Impulse is force into time. So, what are the dimensions of the force? M L T minus 2 into time is T. Time is this is equal to M L T minus 1. Final dimension formula is MLT minus 1. So this is the dimension formula for the impulse. If I want to know the units of impulse, M is the mass, so kg. Okay. L length meters, hyphen I am putting meters. Time second inverse. So finally this becomes kg meter per second. Be careful, this is not minus, this is the hyphen. Kg meter per second. So here afterwards, the dimension formula of impulse is MLT minus 1. From basics we have seen. Finally, the unit is kg meter per second. Suppose if I want to again simplify at the fundamental level only, observe this. This is the force. Clear? What are the units of force? Newton. And what are the units of time? Meter. This is a hyphen I am putting meter. So impulse units directly can also be expressed as Newton meter, or in the MKS system, kg meter per second. This is in the SI system. This is in the MKS system. Here I write clearly. This is SI system. SI system of expression. Okay. This one. And this is MKS. MKS system. Okay, this is MKS system. Okay. Now, let us see another example. Another great example. Here I am taking momentum. Momentum. What is momentum? Mass into velocity. Mass into velocity is momentum. This is the mass into velocity. Mass dimension formula M, velocity LT minus 1. So this is the dimension formula of the momentum. So once again, if I come to the units expression, okay, units, mass stands for kg and length m hyphen this is, and per second, this is the unit in the MKS system. MKS system. That means earlier impulse and no momentum both have the same units kg meter per second in the MPS system. Is it clear? No. Let us see another quantity. Another quantity I would like to take up is work. Work is force into distance. Force into the distance. What is force? Force is dimension formula is ml t minus 2. Distance is L. So this becomes m L square, L into L square, T minus 2. ml square, T minus 2. Okay. Now, coming to the units. In this case, the units are the force. Okay. So force is Newton. Distance is meter. Newton meter in SI system. SI system. If you want to go for the MKS system, mass is kg and this is meter square, kg meter square per second square. This is MKS system. MKS system. Clear? That means if you know the dimension formula of any physical quantity, you can easily find out its units. Okay. Let us see vice versa in the reverse direction. Okay. So I would like to take up example 1 is observe the power. Power. Power is what? Work by time. Work by time. So work unit is what? Joules. And time is second. Joule per second. Okay. Joule per second. What is the dimension formula? The dimension formula is work is ml square t minus 2, time is t. So this becomes ml square t minus 3. The dimension formula for the complete power. Okay. Now, units, from the units, we are arriving the dimensional formula. Let us see. Okay. Now, observe here. This is the known dimension formula, ml square t minus 3. Okay. And units are what? Units are kg meter square per second. This is the hyphen kg meter square per second. These are the units. Okay. Suppose if I know the dimension formula, I am arriving the units. Reverse case, if I know these units, I can easily convert. Kg is what? Mass. Meter square is what? L square. And second is time. Time it comes into the numerator, t minus 3. This is the dimension formula, which is same as to this. So if you know the dimension formula, you can derive units. Vice versa, if you know the unit, you can easily derive the dimension formula. Okay? Right. Let us see another example. Example is, yeah, Same, I am taking the momentum. Momentum. Momentum dimension formula is what? MLT minus 1. So, MLT minus 1 is the momentum dimension. What are the units in the MKS system? kg, meter per second. So, I would like to convert. I know the dimension formula and I am arriving the units. In the reverse, if I know the units, I am converting into the dimension formula. kg stands for m, meter stands for L, per second, T inverse 1. So, from unit, I am deriving the dimension formula. And from dimension formula, I am deriving the units. Both are possible. If you know dimension formula, you can derive units. And reverse, if you know the units, you can derive the dimension. Okay. Another example, let me take up, is that is energy. Energy. Okay, energy dimension formula is what? ml square t minus 2. Okay, so its units kg, meter square per second square. Okay, sometimes if I want to convert into the again in the reverse direction, the energy dimension, again the same process, kg is mass, meter square is L square, second square is in the denominator, it comes T minus. Okay, I hope you understood well. Once you know the conversion, dimension formula to units, units to the dimension formula easily can be done. Thank you.